For those of you who don't know, I'm Josh Smithrood. I'm the team lead for Team Spam.
I'm Patrick McElroy, and I'm the software development lead.
I'm Leonard Patterson. I'm the quality assurance lead.
And for the course of this project, Dr. Andoni is serving as both our client and our advisor.
So a quick introduction to our project. We're going to go through our project overview first to kind of let you know what it's about. We're going to go over our motivation for doing the project. We're going to give you the process model. We're going to give you the requirements that we gathered from Dr. Andoni. And we're going to go over our solution to those requirements. We're going to cover the system architecture, a little bit about IMAP, and then our general focus is going to be on CUDA and KNN. And then we're going to give you some slides of our GUI, and then we're going to finish up with quality assurance and risk analysis.
All right, so before we go any further, one thing we felt was important to emphasize is that this is a research-oriented project. That is one of our primary focuses. The application we're developing is a spam classification and filtration system that uses the k-nearest neighbors algorithm applied on NVIDIA GPUs using CUDA. Our ultimate goal is to prove that such a GPU-based spam filter system is a real efficient, viable option in a real-world setting. As far as email synchronization, we're using the IMAP protocol to synchronize with Gmail accounts. The application itself runs primarily in the background with as little user interaction as is necessary, aside from just basic settings. And then, time permitting, we'd like to implement a fully fledged local email client, much like Outlook, but that was not given as a core requirement.
So our motivation for doing this project is spam is an ever-growing problem. It continues to increase each year, and the data and time required to classify spam increases as this volume of spam does as well. So we believe that there is a scalable solution that exists, and we believe that GPUs offer that solution. So our application aims to demonstrate the viability of the solution, and another key motivation factor is that we actually really enjoyed this research project.
So for our process model, we're using something resembling a waterfall methodology. There are a number of reasons for this. First, the requirements we gathered in our first meeting with Dr. Andoni regarding this project, we received a very concise list of requirements. They're not going to change. The problem itself, spam, we understand it. We also understand the components of our solution, as well as the components themselves from CUDA, KNN, IMAP, and all these components are well documented. As a result of choosing waterfall, we were able to separate out programming foci fairly evenly and separately. My focus has been on the KNN implementation and CUDA. Leonard's has been on the GUI, and Patrick has been focused on the IMAP implementation. Here's a list of our software development tools. The primary ones, language-wise, we're writing most of the application in C#. Aside from the CUDA filter itself, which is written in C, as CUDA is exclusively in C. For our IMAP implementation, we're using mailsystem.net. For the database for our training set, with the KNN implementation, which I will go into further detail later, we're using SQLite. We're doing all this in Visual Studio. We're using Mercurial and Bitbucket, and we're also using Bitbucket's built-in issue tracking.
The functional requirements that we gathered at the start of the quarter are that the system must be able to install on Windows 7 PCs. It has to allow for bidirectional synchronization between the client and the server, so that if the user modifies something on Gmail server, it's reflected within our client and vice versa. The training set that we use for the spam classification has to be able to grow as more emails are added to the database. And additionally, the training set has to adapt to the new types of emails added to the database, be them spam or non-spam. The program itself needs to run in the background with as little user impact as possible. And it has to be able to run on computers regardless of whether or not they have compatible GPUs. If they do have a compatible GPU, it'll use the GPU sort. If it doesn't, it'll just use a sequential version of the algorithm. Additionally, the user must be able to override any classification errors that occur. So if something's labeled as spam and it isn't, they should be able to fix that. And then the training set must learn from this mistake so it doesn't make it again. Additionally, the user will have the option to customize blacklists and whitelists, so they can specify any usernames or domain names that they want to go directly into the spam folder or into the inbox without going through the whole filtration process.
We also got some non-functional requirements from Dr. Andoni, and that was that the system must be easy to use and understand. That it also must operate with as little user interaction as necessary, and we're actually building the system so that it runs in the background, and the only thing the user is going to have to do is set settings. It also must filter spam efficiently when using the GPU and accurately, and obviously this is a research goal, so it has to be viable and hyper-efficient solution.
This is an overview of our system architecture. There's the driver program, which will allow it to run in the background. It's divided into three main components, with the GUI component being what the user would use to set settings. The email interface component, which would be what communicates directly with Gmail's server. And additionally, it will process any new emails that come in, and it will parse it into information or into data that can be used in the spam filtration component. It'll be added to the training set, and if the computer has an NVIDIA GPU, it'll use the GPU filter to sort those emails and classify the incoming emails, and if it does not, it'll just use the sequential filter. To communicate with Gmail's servers, we're using IMAP, specifically mailsystem.net's libraries. We chose mailsystem.net because it's open source, which is important for a student research project. And it allows us the bidirectional synchronization that we need for the project. Additionally, it has a number of other features which will help with the email processing. And our solution is written using CUDA, which is NVIDIA's GPU programming API. Conceptually, the way it works is the graphics card is divided into a number of blocks, which themselves are divided into a large number of threads. And the threads are what allow for the massively parallel symbol computations. Each of the threads within a block are able to intercommunicate. However, blocks are not able to communicate with each other, which presents an interesting communication limitation that we have to work around in our solution, which Josh will go into in the next slide. And thus far, our work has been done on an NVIDIA GeForce GTX 275, which you can see up there. Over winter break, we're going to be trying to get access to more and different types of graphics cards so that our benchmarking can be more rigorous and varied. Yes.
All right, so the k-nearest neighbors algorithm, for those of you not familiar with it, is a classification algorithm. For the sake of our application, the best way to explain it is we have an incoming email that has known attributes that we can parse, but an unknown classification in that we don't know if it's spam or it's not spam. But we have a data set of items that we have both those same attributes or corresponding attributes, as well as classifications. We have a number of spam emails and non-spam emails. By going through this algorithm, we can determine the unknowns classification by comparing it to its most similar components in the data set. The algorithm is essentially broken down into three primary phases. The distance calculation phase, we take our unknown email, we break it down into its components, and we measure the Euclidean distance from that unknown to each and every member of our training set data, at which point we move on to the sorting phase, which you'll notice I have underlined there. The reason for that being it is what drives the complexity of the algorithm. It's the most expensive component. After we have measured the distances of each of those members of the training set, we have to sort it in ascending order such that we can move on to the classification phase where we take the k first elements in that list, the k smallest distances, and therefore the k closest neighbors, nearest neighbors, and based on a weighted average, we classify our unknown. Our preliminary results are on the screen here. We have the number of elements of that training set, which gets fairly large, and we'll plan on pushing that out even further, versus time in seconds. And as you can see, our parallel implementation is significantly faster and is highly scalable. As Patrick mentioned, we're going to try and get access to more GPU equipment, better cards, multiple cards, and we plan to change our algorithm to accommodate that so that we can push this out further and better prove the scalability of our implementation.
So here's a quick example of our GUI. Right now there's no functionality. We haven't connected all the pieces yet. But up top, the user will have accounts where they can add or remove emails attached to Gmail. When including add, it'll open an account form, which will allow them to put in their email account and password and then attempt to connect it. We then have an important part called frequency. For a user who gets a lot of emails constantly, they're probably going to want to keep it updating frequently. And for users who don't get a lot of emails, they may not want it running as often. So they'll be able to set it from checking every minute to up to 12 hours. Underneath that, we have GPU settings. For spam priority, if you are an avid gamer, you probably don't want your spam filter to kick in the middle of an FPS fight. So you'll be able to set your spam priority either first or last, depending on your preference. And also we have the option for you to choose to use your GPU card using all of them, 2 of them, or none. And then below that we have our black and white list managements, where you'll be able to go into these separate blacklist and whitelist forms, and you'll be able to add strings and types for what you would rather to be kept out of your email or not. So like if you are in a work environment and you don't want anything involving mail enhancement or something like that, you can put that into your blacklist and it'll completely avoid the filtration system and just put that in your spam folder. So for quality assurance, I've made sure that all of our progress has been well documented, and as things change, it's been frequently updated. Our coding standards also will be following most of Java's coding standards, camel casing, method documentation, pretty much everything you've learned in any of your Java classes. And for unit testing, Visual Studio actually has a unit testing framework that will be very beneficial for us. Regarding risk analysis, all of our requirements are well documented. We know our end goal and what we're trying to reach, and we don't believe there's going to be any risks that pop up. But to prevent potential issues, we continue to meet daily during our sessions, both before and after, to talk about what we've accomplished. We also hold a once-a-week bigger meeting where we go down and actually sit down and talk about any larger problems that may be coming up. And we also meet with Dr. Andoni weekly to show him our progress and see if he has anything to add or wants us to change.
Looking back on this quarter, we did a number of things well. We had great inter-team communication and cohesion. We functioned very well as a unit. Additionally, our regular meetings with Dr. Andoni have been very beneficial to us. We do recognize that we have a number of things that we'll need to work on for next quarter. Namely, we need to be better about meeting our self-appointed deadlines and using issue tracking and progress tracking to their full potential. Additionally, we would like to have more team programming sessions, which would help up our productivity and be able to facilitate inter-team help, essentially.
So looking forward to next quarter, there are a number of foci that we have. First and foremost, as I mentioned earlier, we've had separate responsibilities component-wise in development. Beginning next quarter, we're going to start integrating those components. And once we have a working prototype, we'll begin all of the benchmarking and results testing. 3 primary focuses we have there. Algorithmic fine-tuning. We want to allow our algorithm to accommodate multiple graphics cards, different combinations of GPU capabilities. We also need to benchmark. We'll be comparing systems with individual GPUs, systems with multiple GPUs, and of course comparing those to our sequential implementation. Additionally, for accuracy testing, we're going to be testing a variety of email parsing methods to really determine exactly what attributes make an email spam or not spam. And then, as we've mentioned a few times, this is a research-oriented project, and excuse me, as a result, presentations are never far from our mind. In addition to the presentations we'll be giving in class next quarter, we will also be presenting at Source, and we hope to be presenting at the GPU Technology Conference that NVIDIA hosts in March in San Jose. We're crossing our fingers. We hope to hear back shortly after New Year. So that's our presentation. Any questions? Yeah.
So I may have missed it, but what is your reasoning for using CUDA over OpenCL for more compatibility?
Ultimately, it's what we're more familiar with. We've really enjoyed working with it thus far, so we thought we would continue that.
Okay. And you mentioned that for your classification, you'd be using attributes and components.
ultimately, we're going to be focusing on text analytics, as well as domains, specific email titles, stuff like that. We haven't thus far gotten too far into that process, but we're going to focus on the text analytics.
Okay. And if I'm willing to donate resources for your benchmarking tests, I have a number of graphics cards, both in SLI and non-SLI. So.
Okay, yeah, that would be great. We'll have to talk to you after.
I forgot to tell you this actually. So it was ongoing. We discussed this before.
Oh, okay. In the back.
Is this supposed to work in addition to like Gmail's current spam filtering? Or how is that?
Ideally, our focus is to, since we're trying to prove the viability of this implementation, it's not really supposed to work in addition to Gmail. It is supposed to, for all intents and purposes, replace that functionality. But since we are synchronizing with their accounts, there's no way really for us to override and tell them to stop filtering. So there will be some conjunction there.
Are you designing for the use of just one GPU or two GPUs with SLI?
So the way CUDA operates, SLI doesn't really grant much benefit. I haven't really been able to determine why that is, but it is actually better to have them separate rather than having them treated as a single card. We will be, currently the implementation we have only works with a single card, but that is one of our next steps, is allowing it to work with multiple cards.
Any other questions?
Just one note here. To answer your question, why CUDA? Of course, OpenCL gives you more flexibility and you could also use multi-cores. The problem is that this is supposed to be presented at the major NVIDIA conference. When you go there, you present the CUDA. That's the point. Very simple. Like you go to Microsoft and present something, I don't know, like it's a very practical reason.
Any other questions?
Can you discuss your plans for user testing?
Thus far, we don't actually have too much of a concrete plan with that regard. Our primary focus going forward has been thinking in terms of the research results. As far as user testing, we're going to have to figure that out.
Well, from what you've shown, you have the research results. You know that this works better than sequential.
With our preliminary, but we have other, we're going to be adding support for multiple cards, etc. That's for user testing. Thus far, the only plan we have in place is us testing and friends and family synchronizing their accounts and giving us feedback that way. All right. Well, thank you for listening.